part D is telling me I still have a mu. I could write that mu is my average observation. And that's part 1, and then that makes my H naught is going to be mu equals 75, and then part 2 H sub A, that's going to come from right here. It says mu is not 75, and when it says not equals, then I know right away this is going to be two-tailed, and that helps me get on the next step. And then 3, this we'll use a Z statistic, and that's going to be x bar minus mu naught over S over square root of n. And then step 4, I want to think about my alpha here. I have an alpha of 0.01. And so when I'm talking about alpha, in this case, I know I have two-tailed, and I want each tail to be half of the total area. The total area is 0.01, and then I want to break that in half and put it on each end. So it's going to be 0.01 over 2, or 0.005 for both ends. And that's how much area I have there. Now that's going to be my rejection region. I need to figure out, this is going to be 0.495, I believe. Yeah, 0.495. So you just do 0.5 minus the right hand side, and you get the area for the big side, the big chunk there. So I want to look up that 0.495, 0.492, 0.494. It's going very slowly. It's right in between these two, so it's going to be 2.575, exactly part way between 2.575 and over here negative 2.575. And so then my rejection region is going to be Z is less than negative 2.575, or Z is greater than 2.575. And what I need to, I could also write that, sorry, as Z is greater than 2.575 with the absolute values on the Z. Okay, so there's two ways of stating my rejection region for this problem. And now I want to go back to my blue because I will do step 5, which is the assumptions. And remember, random sample, and we don't know, n is greater than equal 30, we don't know, and S estimates sigma, and we really don't know that either for this one. Okay, then part 6, this is where we do the calculations. And this is where we would do our actual study and collect our actual data and then do our calculations. So they've pretended to have done the study for us. So what we're calculating now, they've already done that for us too, is they gave us the Z equals negative 1.63. And what that looks like on the chart is we have our 0 in the middle. Remember, this was meant to be a two-tailed, but we have just the left-hand side, which is normal. We have one mean to check, and that's a negative 1.63. And we want to know the area for anything outside of that value that we got for the Z. So to the left-hand side, so we're going to look up the 1.63 and 1.610123. 0.4484, shouldn't be surprising us. So this is the 0.4484 because that's from 0 to 1.63. And then we want to find this little area, and remember that one came to 0.0516, where we're just taking 0.5 minus the 0.4484 to get the area on the very far left side there. So 0.0516. And now what we're looking at here is comparing these two, the red rejection region with the actual data that we've come up with. And so I want to think about a combination of these two pictures where I have, okay, and I have a rejection region way out here and way out here. And then if I come in and draw in my actual data where it came, it was at negative 1.63, so it's actually quite a bit closer to here, 1.63. And we have this whole region here. So you can see that my p-value is greater than my rejection region, and so I'm going to have to fail to reject. And we can also look at our rejection region. We said if our z is less than negative 2.575, we could reject, and our z is actually less than or equal negative 1.63, which is not smaller than negative 2.575. So again, fail to reject. So it's two different ways of looking at that. And we could also look at our areas and look at the areas to tell that we need to fail to reject as well. So this is z-score analysis, and this is p-value and alpha analysis. And you really need to know both ways. You really need to understand both of them, because sometimes you're only given a p-value and you have to compare it to different alphas and see if it's going to reject or fail to reject. So back to our picture. For this p-value for our data, that gave us 0.0516, and that's that blue area. And then if I look at my alpha was 0.005 because I had to have it on both sides. And so you can see here that my alpha is smaller, is less than p-value, fail to reject H0. There's insufficient evidence to reject H0. So a couple of different ways, and I really want you to work with this until you can see it both ways. You can compare the z-scores. You can see that the negative 1.63 is not in the rejection region, but then you can also look at the p-value that we came up with for the actual data and see that for this alpha it's not in the rejection region. And then also you can kind of tell that if you had a 0.1 for your alpha, you would be able to reject. So you can look at it that way, and then it helps you decide what significance level you want to use. Okay, so these are all our step 7 answers.